Hello friends, we will continue the problem in finding out the derivative by using Cauchy-Riemann equation. Second problem, that f of z is equal to e power minus x into e power minus iy. Find f dash of z, right? If it exists, always condition is there. Now corresponding to that, here as I have told already in the first problem, you have to express in u plus iv form. So e power minus x into e power minus iy, you know that this is in exponential form of a complex number, and you know that how to write in the Cartesian form. What is that here? Cos y minus I sin y, and this is equal to e power minus x into cos y minus I into e power minus x into sin y, that is here. Now here what is u term here? Real part minus x into cos y, and what is v term here? V is minus e power minus x into sin y. Now we will find the partial derivative of the u and v, you know that. So differentiate now partially u with respect to x here, so that becomes ux, that is what? E power minus x, e power x derivative is e power x, but minus x differentiation as per chain rule, it is minus 1 into cos y. Similarly, what is uy? In that case ex e power minus x remains constant, treating it as constant. Cos y derivative is what? Minus sin y. Similarly, what is Vx? Vx is minus e power minus x, e power x is e power x, minus x derivative is minus 1, so this term becomes plus there, it becomes sin y. And what is Vy? Vy is equal to minus Ex, sin y derivative is what? Cos y. So therefore, now CR equation is what? CR equation, by CR equations, Ux is equal to Vy. Verify that here. Ux is what? Minus e power minus x cos y. Is it equal there? Vy. It is Ux is equal to Vy. What is it? E power minus x into cos y. That here. You observe that, check that once again, ux minus x, that here it is ux. Sin y derivative is what? Ux is equal to Vy. Sin x derivative is that with respect to y, v to the power minus y, sin y derivative is cos y, that. Similarly, which we have got, that here it is here, which is minus iy, that ux is equal to Vy. Minus term is there, isn't it? Yes, I have left out here minus, this minus term is there, this minus term here it remains as such, minus e power minus x into cos y, correct. Now this is equal to how much? It is minus here, right? So they are equal here. On the other hand, ux is equal to Vy, Vx is equal to minus cos minus uy, that is Vx is equal to minus uy, that is, observe that, what is Vx part there? E power minus x into sin y, that is minus, what is uy here? Minus, this minus and this minus, it becomes plus here, therefore e power minus x into sin y. Now we will observe that both the terms, they are equal, therefore what it implies, therefore CR equations satisfied, holds good at a particular point, right? So therefore what it implies? F dash of z exists, that here, right? So once you have found out that, verified that whether the derivative of that function exists, right? If you are interested to find what is the derivative, so in that case I have given you already the formula here. What is f dash of z? That is ux at a particular point x naught y naught plus I into ux vx x naught y naught, or that is equal to here, in this case what is ux here, minus e power minus x into cos y. Let me take in generally, it is here not x naught y naught, general term, plus I times, what is vx here, vx is here, that is e power minus x into sin y, or you may simplify and write here, what is it, e power minus x is common, that is what here, minus cos y, that here again plus I times sin y. Still you are interested to simplify this here, you can take this minus outside, it minus e power minus x cos y minus I into sin y, that is here, right. You may write the derivative of the function nothing but like this here. So that is what you can write here. Still you can simplify this if you are interested. See, this I can write here e power minus x into, how you can write in the exponential form this here, it is nothing but e power minus iy, isn't it, right here. So this is nothing but what, once again e power minus, using indices law, that is e power minus x minus iy. Still you can simplify this, minus I have observed there, minus is common there, I have taken outside, or what is this becomes here, it is e power minus z here. Therefore you have got that function derivative, it is nothing but e power z is e power z. Observe that this minus I have left out here, this is there, right, this is there, and it is minus is there, here it is, right. What you have got, f dash of z, it is in the most simplified form, you have got minus times e power minus z, right. Actually if you are observed that, if you observed your given function, just for your knowledge sake I am going to explain that once again. If you observe that given function here, the given function is what, e power minus x, what, into minus iy, what is it simplified, minus x plus iy, isn't it. Your given function is like this here, you know that, what is this here, you are writing it in terms of z, yes. So actually by your knowledge directly you can find out the derivative also. What is the derivative here, f dash of z is e power z is e power z, minus z derivative is what, with respect to z you are differentiating, minus e power z. So by your direct knowledge of derivative, if you are differentiating with respect to z there, you have got this here. By using CR equation also you have got the same answer, right. So this is what the method, in the both the method you can find out the derivative of the function, okay. I will take one more example. Yes, now another example here, the third example here, f of z is equal to, let me take slight modification, minus iy, right. So now what is the derivative of the function, find it always if it exists, okay. So now we will find out the derivative of that function if it exists as usual, okay. Now again, as I have explained you, to find out the CR equation you have to express in the form of u plus iv. So this is what, exponential form, that is what here, it is equal to e power x cos y minus I times e power x sin y. So here u is equal to what, e power x cos y, and v is equal to what here, minus e power x sin y, that. So therefore again find out the partial derivative here. So you try that yourself. We will continue the problem in the next class. Thank you.